If you want to figure out what your pump is moving in water for GPM, then you can use this formula here. So it's horsepower times 2800 divided by pressure differential in feet of head. Now, in another video, we went over how to do it to figure out your current operating horsepower, whether it's single phase or three phase. You need to know that. You can't just take nameplate data and put that up there and expect it to be accurate. You need to figure out what your pump is actually using for horsepower at that time. So for example, if our pump discharge pressure is 70 PSIG, our pump suction pressure is 10, and our single phase operating voltage is 230 volts, and we're currently operating at 18 amps, and the efficiency is 0.8 or 80%, and our motor nameplate power factor is 0.9. To figure that out, we're going to use a single phase formula to figure out what horsepower we're operating at. So it's 230 volt times 18 times 0.8 efficiency times 0.9 for power factor divided by 746 watts. Ends up being 2,980.8 divided by 746. So our single phase motor is currently operating at 3.995 horsepower. And now we need to figure out what is our pressure differential in feet of head between the discharge and suction of the pump. Ideally, you're going to be using the same gauge with valves, so that way if your gauge is off, it's off the same both ways. So PSIG-A is your discharge, PSIG-B is your suction, and then your 2.31 feet is your 2.31 feet of head. So you take 70 minus 10, you end up with 60 times 2.31 feet, and then you end up with 138.6 feet of head. So now you can actually use the formula we first looked at, and you plug in your information that you just figured out above. So you figure 3.995 horsepower times 2800 divided by 138.6 feet of head. You end up with 11,086 divided by 138.6. So your actual pump is moving 80.7 GPM if this is water.